So a very good evening to Doctor. My name is Kaiser, and today I'm presenting my PSM1, which is the project proposal. Okay, so based on my title of the PSM1, which is I'm doing the early stage detection of the cryptocurrency scam, which using two algorithms, which is the random forest and the SG boost on the initial token concentration and the early transaction volume. Next, I will move to my project background and the proposed solution. So based on the rapid growth of the decentralized finance has led a massive surge in the early stage of cryptocurrency scams. So for me, I specifically talking about the three scam, which is the rug pull, pump and dump, and the honeypots. Well, although the three of that is work like totally different, but they all share one goal, which they were manipulating the early markets that the means to steal the retail investor funds. So the financial devastation will become massive. And based on my studies, like the Chai analysis crypto crime reports, it addressed like almost received 10 billion scams through 2024 and almost 12 billion scam in 2025. So why are we not catching them? So I have some difference between the existing solution and what I wanted to propose it. So right now, it's a critical gap in the cryptocurrency landscape for like absence of the proactive early warning system. So by the existing the studies, frequently they rely on the models that only trace the stolen funds post incident, which is the money is gone already, they just like help you trace back. So on the other hand, there were like newer early detection models rely on the computationally expensive temporal graph neutral networks (GNN). So they will depends on the heavily on the off-chain data that they were analyzing the unstructured social media. Then so based on my research, I would like take a different method lah. And as I am proposing a streamline purely on the on-chain early warning system. So instead of the heavy networks or the text analysis, this study solely like utilize the early life cycle developed on the on-chain feature. So now, actually, based on my solution, I focus on the two mathematical on the metrics. First, my solution is the initial token concentration, which it will like exposes the incident holder typically in the rug pulls and the pump and dumps. Then next is the early transaction volume, which will exposes the artificial hyper and the restricting selling patterns of the honeypots. So to process this data, I've selected like two algorithms, which is the random forest and the S3 books. This will example like three base models are highly optimized for the tabular datasets and are computationally lightweight compared to like deep neutral networks. They are essentially capable of the detecting the nonlinear volume anomaly typically across the various fraudulent landscape. Then next I will move to like objective. What my objective for this research? Actually, I have three main objectives. For firstly, which to extract and propose such the early stage on-chain features, which is basically on the two ways with the initial token concentration and the early transaction volume from the Ethereum fraud detection dataset. Then secondly, my objective is to train the supervised machine learning models with specifically on the two algorithm we use, the random forest and the SG boost, to focusing on the hyperparameter tuning to maximize the precision and the F1 score. Then lastly, for my objective is to evaluate the benchmark of the trained models against each other, then using the standard classification metrics to determine like the most effective algorithm for the early scam detection. Then next, we move to our scopes. Yeah. So actually I have like four main scope for this. Sorry, I missed the methodology first. So for the methodology for this paper, I have got like four main part, which first I will collecting the data from the Kaggle, which is for the Ethereum fraud detection dataset. Then next I will do the data preprocessing that clean the dataset and really isolate the first 24-hour transaction count and initiate the token distribution to accurately capture the artificial volume spikes. Then third is the modern training. I will train like the primary assembler models for the random forest and the XGBoost on the baseline standard classification. Then classification algorithm like the logistic regression and the decision tree for the comparative analysis. Then for last, I will evaluate the model, which I will benchmark all algorithm. We focus on the accuracy, precision, recall, and the F1 score to determine which model have the minimized false positive and provide the most effective generalized detection. Then next, for for the scope, and actually I'm focused more on the machine language in the cybersecurity part, and I am mainly using the VS Code and Python. So the based on our case study for this, we're using like three. We want to find out like three scam to prevent it, which in the three cryptocurrency scam with the rug pulls, pump and dump, honeypots. Then what data use are we using like the data set for the Kanga. And lastly, my research aims to provide a fast and resource efficient and purely on-chain the method to flag the uh, fraudulent tokens before the investors they lost their funds. So that's all for my proposal part. So thank you.